Hey guys, for the second part of this lesson one video, we are going to focus on simplifying the expressions. So I think the main thing to do is get everything in terms of sine and or cosine. Those are kind of like your basic building blocks. So for instance, if I have tangent, I'm going to turn it into sine over cosine. If I have cotangent, I'm going to turn it into cosine over sine. If I have, let's say, cosecant, oops, or secant, it doesn't matter. Um, I would say, okay, well, that's 1 over sine, and secant is going to be, sorry, I forgot the theta, 1 over cosine of theta. So if you start taking these and turning them into these basic building blocks, a lot of times you can cancel out and simplify things. We've seen little pieces of this, but we're going to really see a lot of it in this unit. So I'm taking this and I'm multiplying it times this. So I'm going to keep that cosine just as is. I'm going to put it maybe over 1 if I need to. And cosecant is 1 over sine of x. So when I multiply these together, I get cosine of x over sine of x. Cosine over sine is cotangent, and so my answer is cotangent of x. So that's how these are going to work. Let me do another one with you, and then I might turn you loose on a few. So let's look at this one. So what's jumping out at me is that this looks like one of the Pythagorean identities that we've talked about. But let's go up and kind of look at those. Okay, so this is the mama and her two babies. And so let's go ahead and talk about, we had cosecant squared x minus 1. So look at this one. And if I subtract 1 from both sides, I'm going to get cotangent squared x or theta or whatever your variable is. Really, if whatever you feel most comfortable with. I don't really care which variable you use. So we found that this is cotangent squared x, and now we're multiplying it by sine squared x. So this is going to become very much like this problem. So see if you can finish it. Okay, so I've shown my work here, and you should have gotten cosine squared x. So the rest of 3, 4, and 5 are just like this. I don't think there's anything weird. So maybe 5. 5 is a little bit difficult, but let's see what you can do on those 3. Okay, 3 started off really basic. There's nothing weird about that. 4, there was one thing weird. So this was one of the 3 Pythagorean identities. That's one of the baby identities. And so that's where I got that tangent squared x. Okay, so when you have like something over something that you need to turn, like I need to turn that into a sine and a cosine. So what I do is think about, I split it up. So this is how I view it. I'm pulling it apart. So tangent on top over 1 and then times 1 over sine squared x. So I'm pulling those apart, and then I'm taking that tangent squared x and turning it into sine squared x over cosine squared x. And then it becomes more normal that way. We cancel and end up with secant squared x. So for number 5, I can't do anything inside. If I could, I definitely would. But there's nothing I could do. So I went ahead and just saw the algebra in it and multiplied them together. And then I ended up getting this. So I wanted to kind of walk you through it from here. So I am looking for anything I can to simplify it. And really my brain goes to those, these 3 Pythagorean identities. So I'm seeing like, how can I make that problem down there work? And so I see this. So let me show you what I'm seeing. So do you see I have this sine squared theta plus cosine squared theta? So I know that mama identity is 1. So my answer is going to be 1 plus 2 sine of x times cosine of x. Okay, go ahead and try number 6. Okay, so you should have seen that everything cancels out and you're left with 1. Okay, when you see this, this is that I'm thinking cofunction. So what is the cofunction of sine? And so we learned that that is cosine. And so this, when you see this is the same thing as 1 over the cosine of theta. Well, we know that 1 over the cosine of theta is secant of theta. And so that would be our answer. So I just wanted to point that out when those come up. Okay, so when we have this is another way of looking at cofunction. So instead of saying 90 minus theta, this is just in radians. So this is 90 degrees, right? In radians, so pi over 2 minus theta. So I'm still looking for, this is a cofunction problem. So the cofunction, let me change colors. The cofunction of this would be cotangent of theta. So I have sine of theta times cotangent of theta. And then that cotangent is cosine over sine. So the sines cancel out, and I'm left with cosine. Okay, so let's see what you can make of number 9, because it's got some algebra in it. Okay, so when I break it up, I'm left with this. And so I think what I'm going to have to do is like multiply these together broken up. So I have 1 over the cosine of x, and then I have sine squared x, because I'm multiplying those together, over the cosine of x. And the reason I'm doing this, my thought process here is we're subtracting, so these have to be the same denominators to combine them. So I'm just going to kind of clean this up a little bit. And something that's jumping out at me is this combination right there. That's coming from that mama identity. So cosine squared theta plus sine squared theta equals 1. So this is equal to the cosine squared theta. And you'll get more comfortable spotting those out. Like it just like is glaring to me. I can totally see that. So because that's cosine squared theta and you've got that cosine on bottom, you're left with one cosine of theta or x on top. Okay, so this is another cofunction identity. So this is tangent of x. So now it becomes just like this. So I have tangent squared x over tangent of x, which is the tangent of x. Okay, go ahead and do 11 and 12. Notice that you're probably going to be dealing with those Pythagorean identities, but other than that, it's pretty straightforward. Okay, so this is my number 11. Notice that I pulled this apart to get that. And notice that this is the same thing as cosine. So I just multiplied these two together and got cosine cubed, or to the third x. On number 12, pretty much I did the same thing. So I found both of these from the Pythagorean identities, and then I pulled them apart. So this is the same thing as 1 over sine squared x, and this is the same thing as cosine squared x. So then I multiplied them together, and that is equal to cotangent squared x. Okay, so 13 is going to pull from those negative angle identities. So this is going to be negative sine of theta, but this is just going to be cosine of theta. So sine over cosine is tangent. So my answer is negative tangent of theta. So those are easy just on the manipulating part, but you just have to know like where the negatives go. Okay, this one, you are going to do algebra. So I'm going to give you a hint. You need to factor it. So see what you can do with that. Okay, so when you factor that, you should come up with this. And so that means that these are going to cancel, and you're just left with 3 minus sine of alpha. This one, because we're adding, we have to have a common denominator. So our common denominator is going to be these multiplied together. So I'm going to go ahead and FOIL those. Because they're conjugates, the middle terms are going to cancel out. So it's going to be 1 minus sine squared x. What's already going through my mind is that Pythagorean identity. So that's going to be my common denominator. So what that means is I need to multiply this side by 1 plus sine of x, and this side by 1 minus sine of x. So on top, I'm going to have 1 plus sine of x plus 1 minus sine of x. So it looks like the sine of x's are going to cancel out. I get 2 on top. And then down here, 1 minus sine squared x, that's going to be cosine squared x. Okay, do not leave them in fractions if at all possible. So if I pulled this apart and looked at it like this is the same thing as secant squared x. So my final answer is going to be 2 secant squared x. And we are done with lesson 1.